Hello, I'm Aurel and I'm doing this hackathon with my partner Victor, and today I'm gonna talk to you about how to use IBM Watson X and how to train your data to data refinery, use the data refinery tool, and to do some feature engineering to your data set itself and to deploy it once. Anyway, we'll see, we go through this together. So here, once you are on the IBM Watson X and you are on the project you just created, here you can see all the data you have. And here what we had is the scenario 1 and 4 in order data set. The other one I'll talk about later, but scenario 1 is the raw data, so just like raw value, like hard to feed to a model itself because it's not normalized. Some of them are way too high, others way too low. And so first, once you have the data set, you need to use the data refinery tool, which is a way to kind of do some math with this data set, create new columns, delete others, and then this allow you to visualize it. So here I'm going to quickly show you how you can create new assets, then prepare and visualize your data set. And over here you need to select the scenario 1 data set over here, put the name, I'm going to put this name, and over here, once you've done it, on the data refinery tool, I'm gonna just show you very quickly, but there are some steps on the left side of the screen over here, and you can create some new steps for, like, let's say I want to calculate on the column which is created as, which representing the time, it's in second. If I want to a new columns which represent the minutes, I can select the division operation and divide it by 60, and I want to create a new columns, and I want to name it almost the same I created at, but I want to say minutes admin for minutes. And then if I apply it very quickly, it will, over here we can see that this is the new column that has been created, and it's very useful, very quick. And so, okay, so once you refine it, you can visualize it. I'm gonna show you what the data set we had to refine, and how we and once we refine it, what's the visualization of it and how it truly helps us to see for how to train a model, how to choose other variable. So here are the visualization. Okay, so here it's what we visualize once the data is refined. Okay, so what we did is that the data set was very big, like 2000 value, and so we did like the average per minute of some value to reduce the data set, because giving too much data set for a model could harm it, so it could like overfit something. So depending on what you want to predict, you have to work on your data set. I'm gonna show you over here. So here, okay, using the data refinery tool, we can see that the correlation between the vibration and the overall effectiveness is inversely proportionate, which means that the higher the vibration, the lower could be the quality of the equipment. And given this and doing some data engineering, we can set like a threshold. Let's say, I think we set it to 0.8 threshold, which means that is either the equipment operational or not. And yeah, I think this is very cool. So okay, after treating the data, and here you can see, okay, so this is just very quickly the notebook that allows you to do some Python using Jupyter around your data set itself. And here this is the value you want to predict over here. So, and here this is the value you have to decide if it's either effective or not. So okay, so once you have feature engineering and once the data set is prepared, I'm going to show you the model itself. So Watson X will decide for you what's the most optimal model. And here I'm going to show you he decided to choose the decision tree classifier, which is we could argue around it, but a core mission of an engineer is to try different algorithms to see which perform the best, like a neural network or decision tree classifier or a decision tree random forest. There are so many algorithms, and it will do it for you, and he will show you what's the most optimal one. And this is where you can see the algorithm he chose for given the data set and given the columns you wanted to predict. He show you what's the best algorithm to use. And then I'm going to show you how to deploy it. So here you can see all the deployment, and here you can see our deployment of our model. And here you can go on evaluation, and here you can try some different try some different value to evaluate it. 0.5, 700, and here if you select predict, okay, it won't work on this computer because I don't have the premium account. You can see I'm limited, so I'm gonna show you what's the outcome of it by our report, which is, I don't know, where is it? Okay, I need to find it. Okay, up over here. And so here this is typically the kind of thing. So you can test it and try some different value. You can see that if the vibration is higher than 7, it will select the operators. It will set it to not viable, and if it's lower than 7, is it viable? And yes, you can test it. And once you can test it, you can just go on evaluation over here and action and configure the monitor. And then here you can try some new data set itself. I'm not gonna do it, but here you can select here on your computer another data set and try to select what the columns you want to predict. Actually, we're gonna do it very quickly. Go here, you go here, here. Okay, here I select the comma for the limiter, and then here. Okay, so here this is all the columns and the name of the columns, and this is the feature. Characteristic means feature, and this is the target, so what you want to predict, which is the overall effectiveness. If it's either 0 or 1, it's like binary classification. And here, and then you send it all to your models, and sadly it won't work because I don't have the allocate capacity, but this is how you can really with the model, this is how you can make some evaluation around it. And yep, I think that's it. Sadly we couldn't go that much far because we don't have much time, and the server was not working very well, IBM. But still, we think, Victor and I, that this is a very marvelous tool, and we surely will use it for future projects, and hopefully with IBM. Thank you for your attention.